Hi, my name is Dan Gerlowski. I'm a professor of economics at the University of Baltimore. And this short video today that I hope you're going to watch and work along with is a supplement to the demand and supply material for our course. And in what our goal is to look mathematically at what happens when we change the equilibrium in a supply and demand model. We're going to continue the problem that we began in the prior video that we created, where we solved for a supply and demand model, and we'll work through that example. Just as sort of a review, in case you missed that earlier video or have gone on to other things, we looked at a setting involving a hypothetical demand function and a hypothetical supply function for Coca-Cola in the city of Baltimore. Our demand function is shown in the box in the middle of the slide that you're viewing, and you can see there that we have the quantity demanded dependent upon consumer income, the price of Pepsi. Pepsi would be a competitor of Coca-Cola, and the price of Coca-Cola itself. We had a supply function for Coca-Cola where the quantity supplied of Coca-Cola depended, of course, on the price of Coca-Cola and also on the price of sugar per ton, because sugar is a major ingredient in Coca-Cola. What did we need to do to work towards an equilibrium? Well, just like when we graph supply and demand models, we have to assume that the things other than price are fixed. So here we assume that the consumer income level is fixed at $30,000 and the price of Pepsi is fixed at $6. When we use those values, we can see that the demand function is given by the quantity demanded of Coke is equal to 30,000 minus 2,500 times the price of Coke. The supply of Coca-Cola is affected by the price of Coke and the price of sugar per ton. And we did earlier, we will fix the price of sugar per ton to be $1,100. Giving us a supply function of negative 3,000 plus 3,000 times the price of Coca-Cola. Just as a review, we solved those equations and we found an equilibrium price of $6 for Coca-Cola and an equilibrium quantity of 15,000 for Coca-Cola. The equilibrium is active and relevant if consumer incomes are equal to $30,000, if the price of Pepsi is $6, and if the price of sugar used in production of Coca-Cola is $1,100 per ton. If any of those three things change in the second bullet point, the equilibrium will change. We want to start thinking about how do we look for that changed equilibrium mathematically. Here's something we're used to seeing. Again, this is a review. Here's a graph of the equilibrium for the supply and demand of Coca-Cola in Baltimore from our hypothetical example. You can see the demand function is blue in color and the supply function is red in color. They meet at a price of $6 and at a quantity of 15,000. Again, what happens if something changes? We know from our pictures that we've seen elsewhere, perhaps in a prior economic course, we need to shift the curves when something changes. We will do that, and we will also try and see what is the mathematics behind the shifting of the supply and the demand curves. So what is it we're going to change? Well, I think what we should do is consider changing the supply of Coca-Cola. So our goal will be to change one of the supply determinants that is not the price of Coca-Cola. And what we will do to achieve that goal is we will change the price of sugar. So let's assume that we're going to change the price of sugar from $1,100 to $13.53 per ton. How could such a change happen? Well, there could be a bad harvest in where sugar is produced, meaning less sugar is available. There could be some monopolistic behavior by the sugar producers, or even more relevant in today's economy, there could be a heavy tariff placed on sugar imports into the United States. Any of those things would cause the price of sugar to be used in Coca-Cola to increase. So if we think about increasing the price of sugar from $1,100 a ton to $13.53 per ton, what's going to happen? Well, in words, we know that that is going to cause a reduction in supply, and we would expect to see, because of the reduction in supply, an increase in the price of Coca-Cola and a decrease in the quantity of Coca-Cola sold. Let's see if we can track that down mathematically. How does the model change? Well, for the demand curve, nothing changes. We assumed values for Y and the price of Pepsi, and we have a demand function given in the top box on your screen right now. The supply function does include the price of sugar, so what we will need to do is recalculate our supply function, and you can see in the lower set of boxes there is our quantity supplied of Coca-Cola, written in terms of the price of sugar and the price of Coke. If we put a price of sugar of $13.53 per ton into the supply function, we get ultimately the bottom box on the page, which shows the quantity supplied of Coca-Cola is equal to negative 4,087.9 plus 3,000 times the price of Coca-Cola. What are we going to do? We're going to set the quantity supplied of Coca-Cola equal to the quantity demanded of Coca-Cola and solve. So as we begin to solve the changed model, we set the quantity demanded equal to the quantity supplied, meaning supply equals demand, and that is written out for you in the first box. In the second box and third box, we begin solving for the equilibrium price. In the second box, we collect the terms that do not involve a price of Coke in them, and we are going to end up with the second box on the page. And then we need to collect the terms that involve the price of Coca-Cola in them. And we end up with 34,087.9 is equal to 5,500 times the price of Coke. From that point, we divide each side by 5,500, and we get an equilibrium price of $6.20. Are we done yet? No. We need to take the equilibrium price and find the equilibrium quantity, and to do that, we can substitute the new price of $6.20 into the supply and the demand function. And there we will see that we have an equilibrium quantity of 14,505.5 units. Now remember, the equilibrium we just found is good for a set of values for the shifting variables. Specifically, it assumes that consumer income is fixed at $30,000, the price of Pepsi is fixed at $6, and the price of sugar is fixed at $1,353. It differs from the first equilibrium that we found because supply shifted. Supply decreased. We know that if the price of an input increases, supply will decrease, and we could ask what a graph of this situation would look like. Well, here we see a graph of the changed model. We labeled the new supply function S new and the original supply function S original. You can see there is a reduction in supply. The equilibrium point moves up along the demand function, and it results in a higher price and a lower quantity in the market. That's what we were attempting to do, and at this point we have developed the changed equilibrium featuring a higher price and a lower quantity. What is our conclusion for now? Well, our conclusion is that we began with an equilibrium value, and we found the equilibrium assuming that consumer income was fixed, that the price of Pepsi was fixed, and the price of sugar per ton was fixed. Then we changed something. We increased the price of sugar. Following along, we saw that the model would tell us what we already knew. We knew that the price would rise. The model tells us exactly how much the price will rise, and we knew the quantity would fall, and the model told us exactly how much the quantity fell. So in a sense, we've been able to show what we needed to show. If you're interested and want to do some work on your own, we can do other changes to the model. If we begin, and again this is on your own, we use our original supply and demand equations, with the price of Pepsi being $6, the price of sugar being $1,100, and consumer incomes being $30,000. What we want to do is compare that with an equilibrium where we change the consumer income. And if you work through the points on this slide, you'll see that I've given you the answer and left the work up to you. If you plug and chug through the math and do it properly, you will find that there is a new equilibrium price and a new equilibrium quantity. And those are given on the slide. So thank you very much for your attention in this short video. I hope we clarified what it means to solve a change supply and demand function.